Alright, good afternoon everyone. Going 2 o'clock. This is teacher Jason again for your Sec 4E math lesson for today. Alright, so for those who are looking out, okay, we are back to our lesson for today, going 2 o'clock. Alright, understand it's a little bit earlier, but let's get to it, shall we? Okay, so a few seconds to 2 o'clock, but regardless, just some general rules over here. Be patient and understanding, observe gracious and respectful behavior, invert in digital space, and lastly, ask good and relevant questions. Okay, moderator, I've started recording already in the OBS settings, so don't worry. Okay, ask good and relevant questions. Alright, so again, for the purpose of the few lessons that you have in Sec 4, what we are doing is, in this case, usually revision, and today we are revising the few things over here. In this case, linking up simultaneous linear equations, coordinate geometry. We have one question that makes these two concepts together. Stay tuned to find out. And also what happens, we are going to refresh your quadratic equations and graphs. And lastly, how to identify certain graphs, functions and graphs in particular. Okay, but in fact, let's have a few recaps down here. So solving simultaneous linear equations, let's recall I have two particular methods to solve. Okay, I'm not looking for the way to solve, I'm looking for the two particular methods to solve. Does anybody still recall what are the two particular methods that we can do to solve our simultaneous linear equations? Whew, that's a mouthful. Okay, what are the two methods I have to solve my simultaneous linear equations? Anybody wants to try? What are my two methods? Very good, Denise. Hi there. Anybody else wants to try? What are my two methods required to solve my simultaneous linear equation? Alright, Millie, that's a good try. But yes, I think you know what I meant. Okay, yes, I think you know what I meant. Anybody else wants to try? What are my two methods? I'm looking for my methods over here. What you have listed just now is actually for the way to solve a particular method. Okay, I'll just wait for a few more seconds for the response. Okay, that's also another method. Okay, don't worry about it. You know the methods, that's good. But what I'm looking for is the two methods. One is the graphical, one is the algebraic method. Okay, and then for the algebraic method, no worries, Millie. I'm getting the key things from you. It is fine. Okay, so for the algebraic method, that's where we have the two methods, substitution and elimination. But let's go on first. What is my graphical method? Graphical method, because we are looking at linear equations. So simultaneous means two linear equations. What we are looking out for is two particular lines and where do they meet. So simultaneous, that means they appear together and they are bound to meet at the same point. So very good, Millie. Correct. In fact, let me just spotlight and see what share with everyone. It is actually just the intersection between the two lines, in this case over here, A and B. Now, in terms of summarizing what the graphical method does, it is actually none other than doing the notion. We draw the graphs of the given equation, we find the coordinates of the points of intersection, in this case A, B, depending what A is, what B is, and following from the coordinates, we just list the solution as x is equals to A. Okay, over here, if it's A, x equals to A. If it's B, y is equals to B. This is going to be my solution. Okay, that's for graphical method if my two lines are drawn and you draw in your graph paper, what's not, yada yada. But next up, what happens is, if you are doing algebraically, which is usually the case over here. Now, what are the ways to solve it? First way, elimination. That means we are eliminating certain stuff. So, example of a way to eliminate, both methods are okay, or if you prefer one of them, it's also fine. But usually what happens is, we will perform elimination if it happens in a particular manner. In this case, say for example, equations like this, okay, I would prefer to eliminate. So say for example, x plus y, 3x minus y is going to be 4. Okay, in this case, I will do elimination because my coefficients of either, in this case, x or y, are the same. So that's the key thing. If you see either x or y are the same numerically, in this case coefficient is 1, we will eliminate. But if it's a little different, say I change it up a bit to, okay, what do you think we can do over here? This is equation 1, this is equation 2. Okay, if I just change it up like this, what can I do first what can I do first in this case? What do I do to make them equal? Yeah, it will still work, but in this case, what can I do? If let's say I want to make y the subject, I understand what you mean, Denise. We can actually just subtract to make x the subject. But let's say I want to make y the subject. I don't want y to disappear. Somehow or rather, I'm thinking of eliminating x. What can I do? Yeah, very good, Denise. Anybody else wants to try? What can I do? I'm eliminating x this time. Okay, in this case, I think most of you got it. We just multiply by 2 here. This will give me 2x, 2y. This will become 6. And then we can just eliminate. In this case over here, that's the notion of adding or subtracting the equation to eliminate the x or y terms. And lastly, from there, we find the value of x and of y. Okay, that's elimination. That's the first part. Now, next up, what we have, sometimes elimination may or may not work because it can be too tedious. That's where most of you will prone to this method over here. In this case, the substitution method. Yeah. In other ways, I also prefer substitution more, but sometimes if things are fast, if we need more time, elimination can be better, as you see from my previous example. But substitution usually is the universal one. It takes longer, but it's the universal one. Okay, universal method that I would prefer as well. If it's for elimination, if it's more convenient, we perform that. Substitution, key things to take note. First thing, one of them should be the subject. Label equation 1. Then we substitute the equation, that's the notion of substitution, into the other equation. Lastly, we just find the value of x and y. That's the notion of substitution over here. Right, now what is the example of a particular question that uses substitution? Okay, again, sometimes the questions may not be so straightforward, and the equations may not just be given to you straight. They can give it to you in the form of a question. Looks very confusing, but that's where we read it carefully. So, what they tell you over here, a fraction when expressed in the simplest form has x as the numerator, y as the denominator. And the key information over here, simultaneous linear equation, we need to form my equations. So they tell you the sum of the numerator and denominator is 22. And the other information, when x is subtracted from the denominator, the fraction becomes this. And then find the original fraction. Okay, so this is an example of a simultaneous linear equation whereby it may not directly tell you x and y, but essentially from here they're asking you to find x over y because of this part. Now, based on this question, we need two equations, right? We need two equations. So from here, can anybody tell me, okay, before we follow up, I want your guidance as well, and we follow through my explanation, what is a particular equation I can come up based on the information over here? In this case, let's go to my green color highlighter first. Green color highlighter. Very good, Jude. Very good, Denise. Perfect job over there. If you give me both. Okay, very good, Jude. Anybody else wants to try? For the green color highlighter one, green color highlight, what will be the equation I can form from there? Alright, very nice. Jude, take note over here. Your right side is correct, the left side is not correct. Look at the question again. But I think most of you all got for the first one. First one, let me write it in green since I highlight in green. Sum of the numerator, denominator. Numerator is x, denominator is y. So x plus y is 22. Or in this case, what happens? I can make x the subject straight away. Why do I say so? Because if you were to look at my second equation, which Denise got it already for me, thank you very much. As the rest, if you look at the top, I form a fraction. X is subtracted from the denominator. What does it mean? Okay, so Jude, your right side is correct, just that I need to phrase a bit. Top side, numerator, has it changed? Yes, not right, so it's just x. The other one, what is it? I'm going to have y minus x. X is subtracted from the denominator. Subtracted from the denominator, so y minus x. So that's where I have 7 over 8. So this is not a linear equation yet. That is where we have to manipulate. In this case, what's the first step we can do over here to manipulate our steps? Okay, it's a fraction. What should we do? What's the first thing you should do when it comes to a fraction? Okay, I'm hearing a good response. Alright, very good. I hear cross multiply. Very nice. Very nice, Midi, just as I want to say it. Very good, cross multiply. Then after that, I have 7y minus 7x. Again, coming to this equation, I will want to actually simplify as much as I can to get me what I want. In this case over here, I will have, okay, 15x is equals to 7y. And from there, That is my equation number 2. Now over here, based on this method already, it is quite clear, but let me bring it down to the floor. Which method will be more preferable to you guys? Elimination or substitution? Okay, I'm seeing a response. Anybody else who wants to try? Elimination or substitution? Which method will be more preferable? Okay, Millie has a response as well. I'll wait for 5 more seconds. Anybody else wants to try? Okay, I have quite a response. In this case, I would prefer elimination because over here, there isn't really a direct way of substitution, sorry. I would prefer substitution because elimination, that's where what am I trying to say? That's where you realize if you see a multiples, that's where you eliminate. I mean, you can multiply by 15, but that's a little bit of a hassle, so substitution will work here. If you can eliminate, it's fine, but your numbers may be too big, and that may be prone to some mistakes over there. So just take note. And for me as well, yeah, it is okay if we can just go for a substitution immediately. That will work as well, but over here, we are working for time efficiency. So in this case, if it's not so clear that it's elimination, just go for substitution. Sub 1 into 2. So that's where I have 15, 22 minus y equals to 7y. And the rest is just solving. 330 minus 15y is equals to 7y. And that's where I have 330 is equals to 22y. And lastly, y is equals to 15. Okay, now, y is not enough. Remember, when you solve simultaneous, you need to solve for every value. So that's where I have substituting y is equals to 15 into, in this case, you have used which equation you prefer. It's up to you. So therefore, what happens? I will sub into 1. Easier, because my numbers are not so big. So that's why I have x is equals to 22 minus 15 is equals to 7. And then, that's it. I stop my answer there. Is this correct? Have I solved the question completely yet? Have I solved the question completely yet? Right, okay, Midi, that's correct. I have not solved the question completely yet. Anybody else wants to try, even though I've given the answer already? Or maybe you want to tell me the reason why for those who have heard it. I have not solved the question completely yet. Why is it so? Yes, that's right, okay. Why would we want to substitute x into 1 again? Because if we substitute x into 1, we are going to get y, which is the same thing. Yes, that's right, Jude. That's right, Millie. Okay, I think, Denise, you are confusing yourself with the many substitutions. Take note. Because what happens? We want the original fraction. Take note, what's the original fraction over here? So, original fraction is x over y, which I have written over here. What is x over y? X is 7, y is 15. Bingo! Then, finally, you can say, aha, I have solved the question. Alright, that's one thing to take note. One example for a simultaneous equation. But however, we know sometimes during exams, they may not just involve one concept, they may mix it together. So let's revise another concept when we talk about the mixture of different concepts. So first one, general equation of a straight line. Y is equals to mx plus c. This should be quite clear. If I talk about x, it's just x axis, x point on the line, y is y point on the line. So the x coordinate, y coordinate. Over here, let's revise. M over here, can anybody tell me what is M on this particular line? What is M over here? Alright, very good, Denise. That's the answer I'm looking for. Anybody else wants to try? Alright, following up nicely. Thank you, Denise. Alright, anybody else wants to try? Alright, very good, Millie. That's correct. Anybody else wants to follow up? Do you want to follow up, Millie? What is C? Or for the rest, anybody else wants to do a good follow-up? Very nice. I'll wait for 5 more seconds. Okay, I think seems like everyone got it. Just that they are keeping it inside because it's quite trivial by now. But it's good that I'm hearing response so that I understand where you are saying. Okay, so that's where we have M, it's the gradient, and C is my y-intercept. Knowing this, okay, you will identify your straight lines better. You identify your straight lines better. Alright, next up, finding the equation of, or finding the gradient of a straight line. Does anybody want to shoot out the straight line equation for me? If I'm given 2 points like this, what is the gradient of my straight line? What is the gradient of my straight line? Okay, I have y2, y1, x2, x1. I understand it's a hassle to write. So I'll give a few more seconds for those who want to try. Alright, that's good. I'm seeing a response already. Very nice. Very good, Millie. But I think your fraction should be the other way around. Okay, because it's rise over 1. What is rise? Rise is y. The y coordinate y2 minus y1 over x2 minus x1. No worries, no worries, no worries. That's why we consolidate. Don't worry about it. So, or otherwise, you can write it the other way. But if you write it the other way, take note the bottom has to be written the other way round. Alright, so take note over here. It's either y2 minus y1 or x2 minus x1, or the other way around, whereby if it's 2 at the bottom, it should be 2 at the top. Or in this case, if it's 1 at the left, it should be 1 at the left, 1 at the top. In this case. Yep. Okay, so just take note. That's right. Now with this concept over here, what is the question that can come about? Okay, so the question that can come about is this one over here. So I believe you may be wondering, oh, why didn't they write the equations down for me? This question is set away whereby you have to identify based on the questions, and I hope one of the lines is quite obvious already. But I'll give it for you a try. This is 3 minutes, launching the bubble launcher in 3, 2, 1, let's go. Alright, so give it a try. Alright, very good. I'm seeing a few responses down there. Okay, I don't know how you answer it that fast. It is not possible, but for those who have yet to try, please try your best to write your answers down, try out the working. Okay, I understand it's very, very long, but I want you all to try. In this case, I have 3 lines over here. X is equals to minus 6. X is equals to minus 6. 3y is this. And x plus y is 9. What do I have? What are my equations? Okay, but I hope that by now, okay, all of you all should be able to identify this line over here is x is equals to minus 6. If not, please revise and go back to Sec 1 lesson, okay, linear functions, to understand why the vertical line is as such. Okay, for the other two, I hope you all can try your best to try and solve, alright, because this is a lot of equations that you need to consider. You have 1 minute and 30 seconds. Let's give it a try. Okay, and I hope from here you'll realize that with this, okay, this line over here, okay, I think for those who are wondering, you all should have known by now. This is this line, and the downward line will be the black color one. And from there, hopefully you're able to get it. Yep, Millie, that's right. I'm glad you have that positive response. Alright, do your best. As such. Okay, 1 minute left for those who are still trying. Give it your shot. Give it a shot. Okay, so let me write down the lines first. So this is, yes, this is as mentioned. Over here, this is as mentioned. Over here, 3x plus y equals to 9. Okay, I have 33 seconds left. Alright, I'm seeing response. That's good over there. That's a nice one. Okay, I have 20 more seconds left. Understand this is quite a tough question. In fact, I would say in the whole lesson for today, this is the toughest question. If you're able to sort of get this, yeah, you're doing good, right? Okay, I would say it's quite tedious as well. But don't worry, for those who have not get it, it's okay. I'll go through with you. Alright, last 3, 2, 1. Okay. Yep, I understand. So that's where we go through. That's where we go through. Alright, that's where we go through. Okay, so over here there's a lot of simultaneous. There's a lot of equations. In fact, not 2 equations, 3 equations in general. So we have this one over here. This is my equation 1. This one over here, my equation 2, and this one over here, my equation 3. Okay, let's do the more straightforward one first. In this case, we can actually go for the straight line. Why do I say it's more straightforward? What I mean by straight line is the straight vertical line, because all of them are straight lines. Apologies for not saying it clearly. Okay, because if I talk about this line over here, okay, it's just the intersection from 1 and 3. In this case, I just sub in, I get minus 6 plus 9 is equals y equals to 9. I have y is equals to 15. Knowing this, immediately I know my coordinate is negative 6 and 15. Next coordinate, easy to solve. It's going to be this one over here. This will be for the blue line. So it's going to be 3. What is my x? Yes. Y is equals to 2, negative 6 plus 3. This is going to give 3y is equals to, in this case, negative 12 plus 3. That's negative 9. Sorry for that. Negative 9. Yes, it's rather tedious. I understand. So henceforth, y is, you create space, apologies for that. Y is, in this case, minus 3. So from there, what do we know? We know equation over here, minus 6, minus 3. Now, the last one is going to be a tedious one, so just follow me, okay? This one, what happens? Depending on how you form 3, you can form it as y is equals to 9 minus x, or x is equals to 9 minus y. In this case, what happens? I will do, let's say I do, I change it up a bit. I let this be y is equals to 9 minus x. So therefore, if I form and solve for the third one, I'm going to have 3, 9 minus x equals to 2x plus 3. Again, it's just going to be solving. So that's where I have 27 minus 3x is equals to 2x plus 3. Solving it further, I have minus 5x is equals to minus 24. Following up, x is 4.8. Okay? Once you have x equals to 4.8, that's where you have to solve for y in this case, because it's not clear. So with that, we know since x is 4.8, y will be 9 minus 4.8, subbing it back to 3, this is 4.2. So therefore, we know my third coordinate will be 4.8, 4.2. And this is just solving simultaneous equations, knowing the lines. Okay, that's the tough part. Once you have this, you realize to find my area enclosed by triangle ABC, what is the general formula we are going to use here to solve for my triangle? Anybody else wants to try? Is it half AB sine C or half times base times height? Anybody else wants to give it a shot? What's the formula we use here? Half AB sine C or half times base times height? Okay, of course there's a half over there. What do we do? Do we do AB sine C or base times height? Which will be better? Okay, looking at the response, that's good. Okay, I see half time base time height. Very good. Okay, in this case, okay, AB sine C as well. Okay, so if you look at AB sine C, Jude, where will be my angle? Yes, in this case, Millie mentioned as well, there is no angle over here, so we try not to make things too complicated. Yes, that's right. So however you can find an angle, it just takes very long. And usually these kind of questions usually won't take too long. Don't worry about it. So we have half time base times height. And can anybody tell me where will be my base? And where will be my perpendicular height? Or in this case, you don't have to tell me where. What is the value of the base? That will be my question. If you know this, that means I think you know what is the value of, what is the base already. What is the value of the base? Does anybody want to try? What's the value of the base and what's the value of my height? Very good, Denise. That's the value of the base. Anybody else wants to try? Alright, very nice. I'm seeing this. The value of the base is actually 18. Because why? If I treat this as my base, this part here can be my height. Yes. Okay, take note. Denise, almost there. That's not my height. 4.2 plus the number you've added is not correct. Yes, but you don't add the number. In fact, you add the height. Okay. The number for the equation is correct, but in this case, I will do 4 plus 6. In this case, 10.2. Okay, because this length is 4.2, this length is 6. What you have given me is the equation of the line. If I want to find the height, this is 6 units long. This is 4.2. So that's where it is the height. And henceforth, this gives me 97.2 units. And henceforth, 3 is the answer. Okay, so this is an example of a question whereby they give you a lot of concepts mixed together. But that is how one particular type of question can come about. Okay, any questions? And Denise, do you understand why is it plus 6 and not plus minus 6? Okay, if all is good, okay. Yeah, no worries about it, no worries about it. Okay, let's move on. So this is one part, simultaneous linear equations and coordinate geometry, how they mix together. Next up, let's go to a quadratic graph. Okay, first one, look at this equation, and based on this, can anybody tell me what will be the shape of the graph? What will be the shape? What's the shape I'm supposed to see? Okay, so take note, y, x minus a, x minus b. What is the shape over there? Okay, it's a positive coefficient down there, so we talk positive. Very good, Jude. Anybody else wants to try? It's going to be a U shape, as what Jude said. Perfect over here. What is my x-intercept? Found a factorized form. What is my x-intercept? Okay, once you get this, I think the rest for the factorized form, it will be better already. Very nice. Very nice, very nice. Giving me the whole thing for me, Denise. Perfect job. Anybody else wants to try? Okay, so I think everybody else roughly know already, but doing good. Alright, so I have x is equals to a, x is equals to b for my x-intercepts. Okay, y-intercept means when x is 0. Okay, I have my y-intercept, just have to be AB. That's an algebraic manipulation. Lastly, turning point is just the middle point of my x-intercepts and then my corresponding y value. Alright, that's my turning point where we have it. Okay, now what happens next up? Okay, what will it be for my this form? Only the shape, because the rest should be the same. Okay, the rest should be the same. Already? Yep, my shape, very nice. This is the N shape, and the rest should follow suit. So x is equals to a, x is equals to b. Y-intercept, the concept is the same. Sub x is equals to 0. Just that the value of y will be negative ab. Just a little different down there. And lastly, my turning point. Turning point, again, take the middle value of my x-intercepts, and then what happens will be the corresponding y value, depending on what your x value is. Alright, now last one over here, another form that you might see, okay, for both sides. Complete square form. Okay, let's revise again. For the shape, what will it be? What will be the shape? What will be the shape of my curve? For this one, okay, if it's positive, take note. Positive coefficient, it will be a, very nice, it will be a, it's not positive, sorry for that, it's going to be U shape. Okay, x-intercept down there, what will I do in this case? This x-intercept is a little bit different, it's not so clear. Okay, x-intercept, follow the concept when the graph intercepts the, x-axis. Very nice, Denise, following up nicely. Anybody else wants to try? Okay, perfect down there. I'm seeing it is sub. A lot of you all say this. Very nice. Sub y is equal to 0. And then from there, just solve it algebraically. It's going to be h square. No, sorry for that. It's just solving for it. X is going to be, yes, h plus minus root of minus k. Now, some of you all may ask, teacher, I cannot square root a negative value. Why do I have a, then how do I solve this? Take note. This will work if my k value here is less than 0. If it's more than 0, of course, it will have no x-intercept. So there's something for you to take note. But as you solve, the main concept is sub y equals 0. And henceforth, for my y-intercept, it will be sub x equals to 0. And you're going to have h squared plus k. And lastly, turning point, take note, last one, turning point. Let's bring it to the floor. Turning point, what do we have? What's my turning point over here? It's right there. What is my turning point? Alright, very nice. I'm seeing coordinates forming up. Okay, very good, Denise. Anybody else wants to try? Very nice, very nice. Okay, so I think most of you all got it. You have HK. Now, if you understand this notion, for the negative side, it will be the same. Shape will be down. X-intercepts will be sub y is equals to 0. Again, your x value will be sub y equals to 0. It is going to be just h plus minus square root of k. Again, this will work if my k is more than 0. Okay, again, it's just algebraic manipulation over here, so don't worry. Okay, so this will work if my k is more than 0. Y-intercept is when I substitute x is more than x is equals to 0, not more than 0. Henceforth, giving me y is equals to h squared, negative h squared plus k. Okay, again, algebraically. Lastly, turning point, if you see this, h and k. But take note, if it's a plus, I want to remind most of you, if it's a plus, it will be a minus h and k. That is if it's a plus. So take note. Okay, now let's move on to your next few bubble questions. I repeat a few because it's really quite a few. Bubble questions for today. Alright, so intersects x-axis, what will I have? Launching the bubble launcher in 3, in 2, in 1, and let's go. Let's see what do we have over here. Coordinates of point P and Q. This should be rather straightforward. Okay, so let's look at the question. Intersect x-axis. What does it mean to intersect the x-axis? Very nice. I'm seeing this over here. Very good, very good. Anybody else wants to try? Right, last 30 seconds. So sometimes a very good habit will be to write down the equation again, which is in this case x equals to, very nice, Millie. Now, using this knowledge, how do we solve? Okay, last 14 seconds. Give it a shot. Yes. What will I have? Very nice. Last 5 more seconds. 3, 2, okay, very nice. Okay, let me see the response. Very good. Okay, so most of you all got it. I think one of you all mixed up with the signs. That's why you didn't get it. But let's see. So, intersect x-axis means what? Okay, you will have y value equals to 0. Now, when you have this, because it's in the factored form, so you just have this over here. Okay, giving this is your zero product principle. You're going to have either one of them is 0 or the other one is 0. Okay, this should be rather in U right now, in calculator in U now. But once you get this, it's going to be x is equals to minus 5. Some of you mix this up because you'll just take the number there. Or x is equals to 3. Take note, it's not the final answer. I want my coordinates. If you leave it like this, you might not get the full credit. You need to write down my coordinates. Negative 5, 0. Or in this case, 3, 0. So that's my P, that's my Q. Alright? Okay, to write it even better, I should actually write it this way. This is P, this is Q. That's why this is my answer over here. Okay, doing good so far from response. I'm saying good things. Now, next one over here, bubble question number 3. Knowing what we have, let me give you the coordinates first. I have from A, I'm gonna give you all the response first, okay? Because this is what is given to you, x is equals to minus 5 and x is equals to 3. How do I find the turning point and what is my nature? Launching bubble launcher, 3, 2, 1, let's go. Okay, what do I have? What's my response over here? What's my turning point? What is my answer? Okay, it's past 20 seconds already. I should see some response over here. Alright, my first response. That's a good sign. For the rest, let's go and see what do we have. Okay, all the stream of responses coming in. That's good, that's good. After the last 10 seconds. Actually, a bit more than 10. Last 5. Okay, let's see the responses. Okay, I do have a mixture, so let's take note. From here, if it's a factored form, how do I find my turning point? Okay, so my turning point, take note over here, is going to be x. Remember, it's the middle point, guys. It's the middle point, so -5 plus 3 divided by 2. This gives me -1. Okay, so from here, we know 2 and 4 are out. So that's one thing we can take note. Now, is it a minimum point or a maximum point? Let's look at my coordinate. It's a negative over here. Negative means maximum point because it goes up, down. So, therefore, finishing up my working, if I were to solve for y first, it's going to be -1 plus 5, -1, -3. Finishing up, I'm going to have -4 and -4 here. This gives me 16. So, therefore, my turning point, it's this one, and it's a maximum point. Because my coefficient, sorry, what am I talking about? My coefficient is less than 0. So therefore, this is my maximum point over here. Alright, maximum point. Alright, doing good, doing good. Alright, next one over here. Next question. Bubble question number 4. Find the coordinate of its x-intercept. So now it's a different question. So now you're given the complete the square form. What is my x-intercept? Launching the bubble launcher again in 3, 2, 1. Let's go. Right, so this should be quite clear. Alright, very nice. I'm seeing all the responses coming quickly. Either you have superpowers or you might have predicted the question beforehand and solved it yesterday when you have the time. But no worries, okay, or you might have attended the previous lesson if I'm not wrong. Yeah. Or otherwise, what happens is, for the rest, give it a shot, alright? Take note of the signs, don't get confused, very, very important. Alright, main thing over here, I'm looking at progression, so think in a positive manner as well, alright? Okay, last 1 minute and 23 seconds. Alright, very good. Seems like my responses are quite towards one side, which is a good thing. Okay, for the rest who are not sure, just let me know how we are doing this, okay? Okay, so now x-intercept is the same thing, just in factored form. How do we do this? Okay, 1 minute left. For those of you to attempt it all, you have some time. Oh, okay. I will take note. Can you submit your answers now, Millie? Okay, got it, got it. Okay, that's a good one. Okay. We will take note. Okay, so this might be a technical issue on our side. We will take note as accordingly. Alright, okay. But I'm glad you submit your answers. That's a good thing. Last 30 seconds. Okay, I'm seeing good response. We have the last 20 seconds. Let's give it a shot. Okay, for the ones who have yet to attempt, you can attempt accordingly. Last 10. Okay, last 5. Okay, let's take a look over here. Alright, so most of you all got it. Again, the notion. Find the coordinates of its x-intercept. So what do we do? X-intercept means what? Sub y is equals to 0. So from here, I have x plus 4 square minus 7 is equal to 0. From there, we manipulate. X plus 4 square is equals to 7. Then from here, when we square root, take note, very important, the plus minus sign must come in. So it is plus minus square root 7. And from there, that's where we solve it. X equals to negative 4 plus 7 or negative 4 minus 7. Alright, solving accordingly, this is where we are going to have your two coordinates. Negative 1.3542. Sorry for that. Negative 135.424, or in this case, the other coordinate, which will be negative 6.64575. But take note, always remember if the digit is very, very long, we take 2 decimal places over here, or 3SF. In this case, always remember 3SF, not 2 decimal places for any general value. In this case, negative 1.35, this is to 3SF. Or in this case, the other one will be negative 6.64, again to 3SF. So that is my answer for number 1. Okay, once we find the x value, key in as a coordinate, that will be your answer. Yep, negative 6.65. Yes, thank you for the note, Denise. Yes, I said 5, but I wrote 4. Sorry for that, but yes, it's a 5. Alright, okay, now moving on again. For this one, okay, you don't need the answer for B, but let's see how you all solve. Launching the bubble launcher in 3, 2, 1, let's go. Okay, you don't need the previous answer, but let's see how you all do it, alright? Okay, very nice. For the rest, let's give it a shot. Who has yet to answer? Okay, this one should be quite okay. I'll wait for a while for the response. Okay, very good. Take note what is the turning point and what are my coordinates. Very important. It's plus 4 now. Remember, I mentioned this in the topic recap. Last 15 seconds. Okay, last 10 seconds. Again, counting down to the last 5, 4, 3, 2, 1. Okay, I have a mixture of responses that's a little bit worrying, but no worries, let's go through. So turning point, take note, it's going to be HK, okay, where H is minus, if I were to rewrite it, minus 4 and 7, I will take these 2 values over here. So my turning point is minus 4 and minus 7, okay? So turning point is minus 4 and minus 7. Alright, now what is the point, in this case, nature of the turning point? Take note, it's positive, so therefore it's a minimum point. Okay, minimum point, why is it a minimum point? Again, looking at the question, my coefficient of x squared is more than 0. That's why it's a minimum point. Minimum point, yes, that's why it's a minimum point. Alright, okay, following up nicely. Doing good, doing good. Okay, next up, another bubble question. Okay, this one should be quite fast. 30 seconds. Okay, I have my turning point. Okay, I give you the turning point. What is the line of symmetry? Launching the bubble launcher in 3, in 2, in 1. Let's go. Okay, this one should be quite fast. What's my turning point? What's my line of symmetry? Very nice. This should be quite uniform. Equation of the line of symmetry. Okay, which value do I take and how would I write it? Okay, when I talk about the equation, how do I write it? Okay, last 10 seconds. Take note, I'm looking for the equation. When I say equation, how would I write it? 3, 2, 1. Okay, let's see the response. Okay, let's take note. Equation over here. It must be something equals to something. In this case, I look at the x value. Okay, because line of symmetry is going downwards. Okay, it's always a line going downwards. Because that's the line that dissects my equation over here. Okay, so it's something like this. Okay, for this graph, it's something like this. Okay, line of symmetry, it will cut the curve into 2. Okay, in this case, I draw it wrongly. Okay, let me draw it a bit more accurately. In this case, for this lesson, okay, so minus 4, right? It should be at the negative side. So this is my line of symmetry. This is my line of symmetry over here. Okay, so that's the notion. Now, a very interesting question over here. I have now, this is like simultaneous and quadratic together. This is my 2 lines. I just want, take note, an equation in x which has the x coordinates of a and b as its solutions. Okay, how do I form the equation? Launching the bubble launcher in 3, 2, 1. Let's go. I just want the equation. What is my equation? Okay, very good. Take note, the line intersects the curve. So what is my equation? Looking at the response, very nice, very good. Okay, keeping it up, you have the last 30 seconds. Last 20. Counting down to my last 10. Hang in there, guys. Last 5, 4, 3. You guys are doing good. 2, 1. Okay, very nice. All of you all that attempted got it right. Perfect. But again, let me just go through the hang of it. So intersection means what? I have my two lines, my line and my equation equals to each other. So what do I need to do? You realize this is actually it. But if you look at all my choices, it doesn't have it. So they are forcing you to simplify a little bit. So 2x minus 1, expanding it minus x squared. Or in fact, if you were to do the actual butterfly method, it will be 3x minus x squared plus 3 minus x. Simplify a bit more. 2x minus 1. I have negative x squared plus 2x plus 3. And therefore, this is my first part. Okay? Option number 3. That is where I have it. Now, next part. You see the word hence over here. Alright? So some of you all may think, okay, if you solve this, you may need A math. In this case, no. See the word here, hence. That means I have to make use of this relation over here. Okay, making use of this relation that we go through just now. How do I solve it? Alright, launching the bubble launcher in 3, 2, 1. Let's go. I see the word hence. What does it mean? Okay, this is from part A. This is from part A of bubble question 7. This is from part A. Alright, very good. Okay, some of y'all can actually eliminate one of the answers because it doesn't make sense at all. Alright, last 20 seconds. Last 10. 5, 4, 3, 2, 1. Alright, most of you all got the numbers correct, but you realize one of the inequalities doesn't make sense. Okay? Because you cannot have a value that is greater than negative 2 and less than 2. Or, sorry, it is greater than 2 and less than negative 2. So it doesn't make sense. So number 2 is actually just a throw option. Okay? Just an option to throw you off. That's what I meant. But let's solve first and see what it means. So from A, if you were to solve this, right, you're going to get negative x squared is equals to negative 4. This gives you x squared is equals to 4. And then therefore you have x is equals to 2 or minus 2. Now from here, what does it mean? Okay, I have minus 2. I have 2. I am looking for the part of the curve where this part of the curve is greater than this part. Now you only have two choices. Either the red one or the green part, because I'm comparing. Because I'm looking at whether this curve is greater than this straight line over here, where I'm looking at the blue color part. So let me identify for you. Or does anybody want to guess? Which part of the curve I'm looking at in order to satisfy this inequality? Is it red, green, or blue? Red, green, or blue? That's why they say hence. Red, green, or blue. Very good, Millie. Anybody else wants to try? Red, green, or blue? Yeah, I'll give 5 more seconds. Oh, yes. Thank you for the note, Denise. This should be 2. Yes, I have Recently, I have always been written wrongly. But yes, I think all of you got it. It's the red one, and henceforth, which satisfies the red one, which is gonna be this one over here. Alright, so that's all the questions for for bubble questions. Okay, now let's move on to the last one, functions and graphs, and that's where we recap all your different functions. Okay, so for this one, it's hard for me to actually do how to draw. So I'm just gonna draw it out, and hopefully you guys recall. If you don't recall, please write it out. Okay, and for me. Okay, linear functions, a more than 0. Okay, this one you know it's gonna be upwards. The other one is gonna be a downwards. If a is less than 0, that means negative gradient. Quadratic function, if it's positive, just now we went through, it's going to be a happy face. Okay, less than 0, it's going to be a sad face. Okay, it should be touching the, you know what, let me draw it nicely. It should be touching. Okay, cubic equation, what function, what does it look like? Okay, it's going to be S. Okay, S-like curve. If it's negative, that means it is reflected the other way, which kind of makes sense. You realize negative means this part becomes negative, this part becomes positive. Okay, so hopefully these shapes looks familiar to you over here. Next up, okay, reciprocal functions, a more than 0. What do I have? I have this part over here. This part of the curve, this is ax. If a less than 0, the other way, reflection about the y-axis. Okay, ax squared, what will I have? I hope you realize it's going to be both pointing up because all your y values will be positive. The other one is all your y values will be negative. Okay, last one down over here. Yes, last one down. Exponential functions. As a function goes up very fast, it's going to be upwards. Take note, the notion is where a is greater than 1. You will not test when a is less than 1. Okay, that one will not be tested. Okay, in this case, you will not be tested where a is less than 0. A is less than 0. Okay, if k is less than 0, sorry for that, this is not correct. K is less than 0, it's all negative. Negative downwards this way. Okay, now next one. If it's in between, this means what? My function is decreasing. So therefore, it's either going to be all positive or all negative this way. Okay, so this is just to familiarize the shape of the curve. If you're unsure, please refer to your Sec 3E lesson on the graphs of your different functions. Alright, now, I think there's a little, yes. Okay, hopefully this is refreshed. Now, we just have 3 more bubble questions to recap and we are done for today. Alright, just hang in there with me. 3 bubble questions over here. Now, next up, let's refer to first bubble question number 9. Very fast. Look at the equation. Look at what it looks like. Launching the bubble launcher in 3, 2, 1. Let's go. What do I have? Wow, that's very fast response for everyone. Good job, good job. Doing good, doing well. Doing so well. Alright, last 40 seconds. Yes, that's right. Because there's no working. It's just pick a possible equation. It's just, there you go. But good job. Hopefully you got it right. Okay, because I can't see who got it right, who did not got it right. But no worries. Let's see what we have. With the last 30 seconds, key the response as fast as you can. Last 20. Last 10 seconds. Last 3, 2, 1. Alright, most of you all got it. This is an exponential curve, so therefore you have this option over here. So some of you may wonder, what is this option then? Okay, you can plot a few functions. As x goes to a very high value, this goes very low. As x goes to a very low value, this goes very high. So in fact, your number 4 will look like this. For those who are interested, this is for number 4. This is for 4. Okay, this is for very large values of x. You can try. You submit large values, key in your calculator and press it in. You will get a very small value. Okay, this is for a very small value of x. Again, this is just for y'all to try, for those who are interested, to know how your number 4 looks like. Number 4, right? Yes, number 4 looks like. Okay, that's for number 4. But otherwise, okay, I'll just freeze the thing for the recording. But otherwise, okay, you don't have to take note of this. This is number 1. Okay, now 2 more to go. Just bear with me. 2 more questions to go. What is this equation? Launching the bubble launcher in 3, 2, 1. Let's go. Okay, very good. Okay, I think some of y'all got trick over here. Take note, what is my intercept over here? What is my intercept? Millie, do you mean this question? Previous one. I'll get back to you later. Yes, it should be the same. Yes, it should be the same. Maybe I didn't label correctly. I will take note. Yeah, it's not in proportion sketch, but yes, it should be at 1. That's right. Good note over there. Very good note. Alright. That means your concepts are strong over there in terms of the graph. Okay, last 10 seconds over here. Last 5, 4, 3, 2, 1. Alright, most of you all got it. You all realize this is a x cube curve. And in this case, how do I know whether it's 3 or 4? Some of you answer 3, some of you answer 4. In this case, it's 4. How do I know? Because this is my y-intercept. When x is 0, it should be a positive value. So that's why I have number 4. Alright, now last one to finish up for today. What is my graph sketch? Launching the bubble launcher. It's, yep, that's right, Millie. That's a good note over there. Thank you for the note. Alright, last one for today. Bubble question number 11. Launching the bubble launcher in 3, 2, 1. Let's go. What is it? Which one is it? If you look at my reciprocal curves well, you should get this quickly. Alright, we have the last 50 seconds. Alright, seeing the response. I am glad to see the response over here. That's good. I have about 30 more seconds. I have the last 20 seconds. Right, last 10 more seconds for those who have yet to key in your response. Right, last 5, 3, 2, 1. Alright, looking at the responses, this looks good. Alright, so for those who did not get it correct, let's just refer. This is a reciprocal curve, but in fact it's not square because square both have to be up. So 1 and 2 is out. Okay, but in this case, which one is it? Take note, this is, in this case, just key in a few values. When x is a positive value, is y positive? Okay, if it is, this is number 3. Sometimes if you are confused with the graph, you can plot a few values to try. So say for example, give yourself a trick when x is 1. Y will be, in this case, let's say, this will give me a positive value. When x is 1, say somewhere here, y is positive. Which one is the one likely give me positive value when x is 1? Look at it, number 3. Okay, so that's how we actually identify based on the graph, and you have to know your graphs. Or sometimes when they give you this graph, you have to identify and from there know the characteristics. Some type of questions will come out like this. Okay, but with that, that's it actually for today. We have a try yourself in the form of a quadratic functions. Okay, so this is actually 2 slides. One, they give you the table of values, and after that, you have a string of questions. 50 bubbles up for grabs. Good for you to know your graph sketching in accuracy. And that is what you have to know. Alright, so do the try yourself. Okay, have some bubbles up for grabs. So not only you know your concept, you get to actually get some bubbles as well for some gifts that you reward yourself accordingly. Right, so what have we touched on today? The equations, simultaneous linear equation, coordinate geometry as well, quadratic curves, functions, and graphs. And that is actually it for today. Alright, so if you have any questions, I'll stay for 5 minutes or so for a little quick Q&A. Otherwise, this is Teacher Jason signing off, and I'll see you all same time next week. Alright, take care everyone. Bye-bye.